So we've really done a lot of heavy theoretical algebraic manipulation and things. And I thought it'd be just kind of nice to kind of come back and revisit our Maclaurin series. So remember, Maclaurin series are what we call a Taylor series when the center is at 0. And there are 3 Maclaurin series that you really should memorize because they are series that happen that are asked about a lot. So e to the x, which is the series where n goes from 0 to infinity of x to the n over n factorial. Sine of x, which is the series where n goes from 0 to infinity of -1 to the n alternating, x to the 2n plus 1 over 2n plus 1 factorial. The 2s plus 1s are the odd numbers starting at 1. And this makes sense because the sine of x is an odd function graphically. Cosine of x is an even function graphically. So it's the series as n goes from 0 to infinity, -1 to the n, alternating, x to the 2n over 2n factorial, where 2n is the even number starting at 0. And we've looked at how we can differentiate and integrate series to get new series. But it's actually, I can do all of the operations to do this. So I can add them, subtract them, multiply, divide, compose. So we can even do composition with this. So it's a way for us to, if we have memorized these series, build other series that are operations on those. So for example, if I want to write the Maclaurin series for the function x times e to the x squared, I know the Maclaurin series for e to the x is the series where n goes from 0 to infinity of x to the n over n factorial. So I'm going to take this and build up to this. So the first thing I notice is it's not e to the x, it's e to the x squared. So e to the x squared means replace the x with x squared. So I have the series where n goes from 0 to infinity. I replace x with x squared over n factorial. I could simplify the algebra in that series, but I'm not required to, so I can leave it like that if I want to. Well then, I need to multiply e to the x squared by x, so I'm going to do x times e to the x squared, which means I'm doing x times the series where n goes from 0 to infinity of x squared to the n over n factorial. Now, in the series, n is the only thing that's changing, so x can be counted as a constant multiple. So I can put the x inside. So I have the series where n goes from 0 to infinity of x times x squared to the n over n factorial. And here is the series. Now, typically, we are asked to write the first 3 non-zero terms and the general term. So in that case, n is starting at 0, so I would have x times x squared to the 0, which is 1, over 0 factorial, which is 1, plus n would be 1, x times x squared to the first, which is x squared, over 1 factorial, which is 1, plus when n is 2, x times x squared squared over 2 factorial, which would be 2, but I can also write it as 2 factorial, plus, and then my general term would be what I have there, x times x squared to the n over n factorial. And this would be the first 3 non-zero terms and the general term. It's really kind of nice. So while I know it's annoying to have to memorize a Maclaurin series, without that, we would have had to go through the work of, okay, what's the first derivative? What's the second derivative? What's the third derivative, et cetera? Then what are the patterns so I can generate my term? It saves us a lot of time. With a second example here, I'm going to write the Maclaurin series for the function t squared times the cosine of 8t. So I notice cosine, so I'm going to start with the fact that the Maclaurin series for cosine, and it's going to go from 0 to infinity. It has to alternate, so I have -1 to the n. And then cosine is an even function, so it's going to be the even powers of x over even numbers factorial. Oops, don't want to use an x though because it's cosine of t. So replace the x with a t. But then it's not the cosine of t, it's the cosine of 8t. So that just means replace t with 8t. So I now have the series where n goes from 0 to infinity, -1 to the n, the quantity 8t to the 2n over the quantity 2n factorial. But then I need to multiply that by t squared. So I have t squared times the cosine of 8t is going to be t squared times the series where n goes from 0 to infinity, -1 to the n, quantity 8t to the 2n over the quantity of 2n factorial. But according to my series, n is the only thing that's changing, so I can put the t inside the series. So this is the series, n going from 0 to infinity, -1 to the n, t squared times the quantity 8t to the 2n over the quantity 2n factorial. And there is my series. Now again, I'm typically on the AP exam asked for the first 3 non-zero terms and the general term. So n would be 0 to start with. -1 to the 0 is +1 times t squared times 8t to the 0, which would be 1, over 0 factorial, which is 1. Then I know it's alternating, so I'm going to have a minus. N is 1, so there's where I get the minus. T squared times 8t times 2 times 1 is 2 over 2 factorial. Then when n is 2, I have a plus t squared 8t to the 4th over 4 factorial. And then the next term would be a minus, and that's going to keep going. And then my general term, -1 to the n, t squared times 8t to the 2n over 2n factorial. And this would be my first 3 non-zero terms and my general term.